Every asset's maintenance strategy should change the moment the data proves a better way. But here's the truth. Reliability as a discipline is still stuck between 1970s RCM and spreadsheets. The 2025 State of Smart Manufacturing report confirms it. Manufacturers are collecting more data than ever, yet only 44% of it is used effectively for decision-making. That's the gap we aim to close. Using AI to turn raw plant data into strategies, engineers can review, approve, and implement. First, we need connected, trusted data. Platforms like Snowflake can aggregate SAP work order history and equipment data, notifications and downtime logs, labor and parts costs, and IoT and historian sensor feeds. This provides a single structured data set, solving what the report lists as a top 5 internal obstacle, capturing and contextualizing data to improve performance. From this data set, we fit Weibull distributions for each failure mode. Beta, the shape parameter, means infant mortality, random, or wear out. Eta, the scale parameter, means characteristic life. Gamma, the location parameter, means failure-free period. For example, a gearbox bearing with beta equals 2.3, ETA equals 8,100 hours, and gamma equals 0, a clear wear-out pattern. This is where AI already plays a role. Automating model selection, curve fitting, and confidence testing. Tasks that take engineers hours today. With failure patterns identified, the system generates options. Stay with the current SAP plan, for example, a 6,000-hour replacement, shift to condition-based maintenance using the PF interval, adjust interval-based replacements, or use a hybrid approach. Here, AI acts as a strategy generator, proposing alternatives based on distribution fits, PF windows, and cost assumptions. Engineers don't start from scratch, they review and refine. Next comes the cost-benefit engine, where AI is again critical. It simulates life cycle outcomes under each strategy. Downtime cost, lost production times mean time to repair, maintenance cost, labor, parts and intervals, risk cost, safety, hidden failure, and environment, and spares penalties for stockouts. Example results. Current TBM is $1.25 million per year. Downtime heavy, CBM is $0.98 million per year. Hybrid CBM plus interval cap is $0.94 million per year. That's a $310,000 saving per year with reduced unplanned downtime. This reflects what the report shows. 55% of manufacturers now pursue sustainability through efficiency gains. Better strategies save cost and resources, and crucially, the engineer stays central, the reviewer and approver. They can edit assumptions if conditions changed, flag hidden versus evident failures, adjust PF intervals, downtime rates, or spares costs, and rerun the simulation with new values. Only once the engineer approves does the system write back to SAP or CMMS, updating strategies, cycles, task lists, and spares with a full audit trail. This fits the report's key insight. Smart manufacturing requires more skilled people, not fewer. AI provides options, humans make the call. This workflow starts with one critical asset, a gearbox, a pump, a conveyor. But once the architecture is in place, it scales fleet-wide. Pareto charts of bad actors by cost of unreliability. Heat maps of beta values by asset class. Watch lists of low MTBF equipment. Ranked candidate strategies by ROI and data confidence. This reflects what the report highlighted. 81% of manufacturers say external pressures are accelerating digital transformation. The pressure is here. The tools must match it. So where do we position ourselves? At NextGenMaint, we are not trying to build the queen, a fully autonomous reliability system. We are building the rook of this architecture, the decision support layer that translates data and analysis into clear maintenance strategies. Our toolkit accelerates FMEAS, Weibull modeling, and cost-benefit reviews today. And over time, it will integrate with data platforms like Snowflake and ERP systems like SAP, becoming the bridge between raw analytics and approved strategies. This is the closed loop we are building toward. Data aggregated, failures modeled, options generated, costs simulated, engineers reviewing and approving, and strategies flowing back into SAP. It's AI-driven reliability, one critical asset at a time. And in the long game, AI-enabled reliability will be as indispensable as a SCADA is today. Join us as we turn this vision into practice and make AI-enabled reliability as indispensable as a SCADA is today.